In this lesson, we will use factor trees to find the prime factorization for a set of numbers. Before we begin talking about factor trees, we first need to talk about prime numbers. A prime number is a positive integer greater than 1 whose only factors are 1 and itself. So on algebraclass.com, there is a lesson on prime factors if you want to review it. But just a quick review, the number 2 is a prime number because the only way to get a product of 2 is to multiply 2 times 1. There's no other way. And because its only factors are 1 and itself, this number is considered prime. The prime numbers to 50 are the following list of numbers. Okay, and these numbers are going to be important as we begin talking about how to use factor trees to find the prime factorization for a set of numbers. So let's just jump into an example, and I'm going to start by finding the prime factorization for 175. 175 is a pretty large number, and it might be hard to think of all the factors. And that's why we would use a factor tree to find the prime factorization. It's a much easier way of finding all the factors, or finding factors for 175. Finding the prime factors, I should say. So 175. A factor tree is simply branching off of a number, and that's why it's called a factor tree. So we're going to branch off of 175, and we're going to think of two factors or two numbers that we could multiply together to get a product of 175. Since 175 ends with a 5, I know that it's divisible by 5. So that's what I'm going to start with. So 5 times what number is 175? And I know that 5 times 35 is 175. So what I've done here is just create two branches, and I'm going to, underneath of that, write the two factors that will equal 175. So 5 times 35 is 175. Now, I want to look to see if either of these numbers is prime. 5 is a prime number. And so since I have 5, I know that I'm not going to continue factoring the 5. I'm just going to kind of bring it down as I continue factoring. It's just going to remain 5. I stop factoring when I get to a prime number. But 35, now that is not prime because 35 has other factors besides 1 and 35. And I know that 7 times 5 is 35. So I'm going to branch off 35 and write 5 and 7, since 5 times 7 is 35. Now I need to check these two numbers to see if they're prime. We already know that 5 is prime, and 7 is also prime. So once I get to a point where all of my numbers are prime, that's when I can stop and I have fully completed the factor tree. Okay, so 5, 5, and 7 are prime. And that's where I can write the prime factorization for this number. So the prime factorization is just simply multiplying all the prime numbers together. So I have 5 times 5 times 7. Or I could write that as 5 squared, since I have 5 times 5, times 7. So this is the prime factorization for 175 using a factor tree. Okay, now just to make sure that you're clear on how to do this, let's do one more example together. And this time we're going to find the prime factorization for the number 250. Another pretty large number, which is when we use factor trees the most. So 250 is my number, and I need to think of two factors, two numbers that I can multiply together to get 250. So I'm going to start with 5 times 50. Now, you might start with something different. You might start with 25 times 10, and that's fine as well. Okay, and maybe we'll do that together as well to show you how sometimes you can do it a different way and still end up with the same answer. Now, sometimes when I'm factoring using prime factorization, when I get to a prime number, I'll circle it instead of bringing it down. And that's fine too. I'm going to circle 5 because it's prime. I'm not going to continue factoring that number. But I know that 50 is not prime. So I can continue factoring by branching off and thinking about what two numbers can I multiply together to get 50. Well, I know that 25 times 2 is 50. 25 is composite. It's not prime. But 2 is a prime number. So I'm going to go ahead and circle 2. And now I'm going to continue with 25 because it's not prime. And I'm going to branch off and think of two more numbers that I can multiply together to get 25. And its factors are 5. But I know that 5's prime, so I'm going to go ahead and circle it. Now, once I've come to this point, I know that I have all prime numbers and I can stop. So I'm going to take the numbers that I've circled and I'm going to write them out. So I have 2 and I have 5 3 times. So I have 1, 2, and 3 5s. So this is the prime factorization, or I can write it as 2 times 5 cubed. Okay, so that is the prime factorization for 250. Now, I do want to show you very quickly how sometimes I'm going to kind of use the space right here in the middle. That prime factorization is not always done exactly the same way. Remember I said that I used 5 times 50 here, but you know that 250 ends in a 0, which means that the number can be multiplied by 10, and that's a pretty easy fact to remember. 10 times 25 is 250. Now at this point, 10 is not prime, and neither is 25. So I've got to branch off again for both numbers. So for 10, I know that 5 times 2 is 10. And for 25, I know that 5 times 5 is 25. And now I need to check and see, well, 5 is prime, 2 is prime, and we know that 5 is prime. So here I've come to a point where I have all prime numbers and I can stop. So my prime factorization is 2 times 5, or 2 times 5 cubed. But notice that even though I did it a different way, I still came up with the same answer at the end. And that's true for any number. There are many different ways to find the prime factorization, and you'll still end up with the correct answer.